Hello, everyone. So today we're doing something pretty cool. We're hopefully going to get to finish off our map setup. We're going to be able to write some text basically in external files in our resource folder here, and then load them as a map, and it'll, call this chunk and sprite group stuff that we did last time, and generate all of the graphics data we need for it, and then draw it for us. So at the end of last time, we finished this chunk constructor here, which is a bit tricky. There's a lot of logic going on. I added some comments to the GitHub branch, so if you want to look through those, I'm not going to explain them here. But what we ended up with is at the very end of our constructor, we go through this sort of list of maps that we created in the constructor and actually create a sprite group with each one. Now, this doesn't compile. And this is intentional. Like, we didn't mess up here. But this, I sort of want to make a big deal of this. Let's read the error here. Sprite group, R value reference. Attempting to reference a deleted function. So it's trying to call the constructor here. That's what this is. So engine is the namespace, sprite group is the class, and then that is the method, I guess, but it's also just the name of the class because it's the constructor. And then the parameters that it's talking about are this one here. And of course this doesn't exist. We deleted it. And this is why. Like, if we hadn't deleted this, this will compile just fine. Oh, well, we hadn't deleted both of these, it would compile just fine. But there's a pretty big error in this, which is that in our sprite group here, when we push it back here, or really this should be in place back, because we're just giving it the argument. So when we in place it into our vector there, one of two things happens. First, it tries to move it using standard move, which we talked about before. But then, as you saw there, if I get rid of that, it'll also try to just copy it using the copy constructor. Or, well, I guess so. First, it tries to do the copy constructor, then it tries to do the move. And we've deleted both of those intentionally because our sprite group class in particular has this pointer here. This is a render object, and when our sprite group destructor is called, we delete that render object, which again is correct because as you can see in our constructor here, we allocate that on the heap, so of course we need to delete it when we're done. But the bug comes from the fact that if this object that we pass into our vector, if there's a sprite group that's created, the sprite group constructor will run, right? And that will create this object on the heap. And then it's copied using the copy constructor, and the new, like the copy of it, is put into our actual vector. Now, the original version of it, the one that was copied from, will go out of scope when this method ends, because it's essentially a variable local to this method. It's not in our vector here. The copy of it is in the vector. So the original one, it'll probably go out of scope within this loop, like the next iteration of the loop. And when something goes out of scope, its destructor is called. So that render object pointer that was just copied into our new sprite group, the one that's actually in our vector, will now have been deleted. And the pointer will still exist, but it won't be valid. It won't point to anything. It'll just be garbage. And clearly that's not what we want. And the way we get around this is with a proper move constructor. And this is why we deleted it, because like we could write correct copy and move constructors for every class. That's unnecessary though. Like you really don't end up using them that much, so it would kind of be a waste of time. But also, I think like you don't need to use them that often either. Like I prefer to leave them deleted and just sort of not use them really as much as possible. But that's just me. That there's not really a reason behind that. I just think that when you start using them, it makes it more confusing. But anyway, so we've deleted it here. So the compiler is yelling at us, which is perfect. Because as you saw there when I commented these out, the compiler didn't yell at us, even though there was that error I just described where we're deleting this and then trying to get it from a different place, basically. The compiler can't catch that, but it can catch when you've deleted these. So that's why we did that. So the move constructor, there's sort of like two, well, I guess there are three important parts. First important part, for any non-pointer variables that your object contains, you either move or copy them into the new object, the object that is being created with the move constructor. So that's step one. Step two is for any pointers, you also copy those pointers in there, but then within the body, you set the original object's pointer equal to null pointer, so that when that original object's destructor is called, when it goes out of scope, you're just deleting null pointer, which is not an invalid operation. It's defined to do nothing. It's like a perfectly fine thing that just, it's basically a no-op. And that's what we want, because we want to sort of transfer ownership of our render object, or whatever pointer we have in our original object, into the new one that we're sort of moving it into. So let's write this out here. We have mRenderObject equals group.mRenderObject. And then mSprites. We could here do group.mSprites, and that would work. But this uses the copy constructor. We can actually be a bit more efficient, I think, and use standard move to pass that as an R value, and it'll call the move constructor on the vector. Which should do no copying, because I'm pretty sure everything in a vector is on the heap, so it just has to sort of do what we're doing here and move pointers around instead of actually copying elements. Okay, so this is step one here. We copied non-pointer objects. This is step two. We copy the pointer object. Step three is setting the original object's pointer to null pointer. So we have moved ownership of our render object to our new object, to our new sprite group. And you'll also get often this little green underline that says it may not throw, declare it no except. That's just for like the C++ exception system, which I've never used, but there's no reason not to put it there. So now if we compile, everything should work just fine. And there we go. And we'll see this several more times. This was just sort of the first one, so I wanted to make a big deal of it. Okay, yeah, so we have, I guess, just a bit of a recap of what we did last time. These classes, what they do. Sprite group is, as I've said, it's a single render object, so just like basically a vertex array, an index buffer with a bunch of stuff, and it has a vector of sprites. So it's designed to draw objects that use multiple sprites at the same time, which is sort of a process called batch rendering, which just makes more efficient use of our GPU by allowing it to parallelize even more operations by using all of the available texture slots on it, instead of just the one texture slot at a time that we were using before. So that the sprite group is like responsible for actually drawing this stuff. The chunk takes in a bunch of data, takes in one of these chunk constructor objects, and we're going to come back and add more stuff to this, but for now it just contains tiles, which is like a small little struct we made that has a sprite used to draw out a position, the like x and y coordinate in simulated pixels of its bottom left corner, and then these other fields, layer and rigid, which we aren't going to use yet. So it just takes in a list of these tiles, which will come from a map, which is what we'll be doing today, and then it sort of splits them up into groups, basically, and creates sprite groups from those groups. So yeah, so we have like two of the three parts necessary here. We have getting data and splitting it up appropriately, and then we have taking that data that is split up and turning it into a form, like generating all the vertex stuff necessary to actually draw it. The one step we're missing is getting the data in the first place, so reading in from a file. And that's what our map is going to do. Eventually we will also have sort of like a fourth level, I guess you can think of it, called world. But that's not really the same thing. It's more of just like combining a map and some other stuff together. So it's more of a convenience thing. It's not really another layer of abstraction or like another part of this process. So basically what I mean by that is that today when we finish our map, we should have everything we need to create worlds in files and then load them into our game. So our map class is substantially bigger than our chunk and our sprite group. These are pretty simple classes. Like they have these draw methods, obviously, which are really simple. Their constructors are pretty complex, I would say. They're not very long, but what they do is sort of, I don't know, hard to think about, I guess. They do a lot. But our map class does way, way more. So I think before we start writing this, I'll just give you a short little example of like what a map file would actually look like. I'll just create a map.txt in my resources here. And you could call this map.map or whatever other extension. It doesn't matter. It's just going to be text data. So the way we write our maps, there will be sort of three like top level components. The first is the simplest. It's very boring. It's called setting or settings. And this just allows you to set stuff like the clear color, so RGB of that. So if you wanted red, you could do that. Or if you wanted yellow, you could do that. It lets you set the like scale or the pixel size, which is equivalent to this in my main file here, the .pixel size part that we pass to our engine instance. So you can set that to whatever you want. And then when you're done setting everything, like in that sort of block of settings, you write end, and that'll let the map system know that I'm done setting settings and I'll move on to a different block. So that's one top level block, is the settings. The second is the chunk, and this is similar. It has an end token at the end that's necessary. The start of this, I guess you could think of it as like taking arguments. It takes an X and Y for the bottom left corner of the chunk. And so everything that is all tiles within that chunk will be offset by this amount. So if you just wanted it to be at the origin, you could do this. If you wanted it to be offset to the bottom left of the screen, you could do like negative 100 pixels in both axes, something like that. And within this, there will be three different things that are not, they're like subcomponents. So this setting and this chunk, I call them top level components. There's like these blocks that you have to define with the name of the block and then an end. These other things, they don't need an end. They're just like a single line statement that will be added to our chunk. So the first is tile, and that'll take a file path. So I could say like res/test.bitmap, and then it'll have X and Y coordinates, like the number of frames and the time per frame. I don't remember the exact order. And then we'll have like layer and rigid, even though we're not using those yet. Then a sort of similar one is rect, it's basically just a macro for creating a bunch of tiles. So you give it all the same stuff that you would give to a tile, but then you give it like a width and a height. So this would create a 10 by 10 grid of this tile, essentially. The third thing is a light, which we're not going to do just yet, but I'm just sort of showing you the end goal here. So a light will have like an XY coordinate and intensity from 0 to 1, and then color. So if you wanted a blue light, you could 0 red, 0 green, 1 blue. So that would be a light. Now the third like top level component I think is interesting. I think it's the coolest. It's called a pattern. So we have to start and stop it with the end there. And what a pattern is it's basically a chunk. So I could take all of this stuff. It takes the same stuff as a chunk can take. But the argument to this pattern, I'll call them arguments. I don't know. It's probably a weird way to say it, but like these are the arguments for the chunk, and the argument for the pattern is the name. So I'll call that pat. And then you can reference a pattern within a chunk at a given offset. So I could say pattern pat and then give it like the XY offset that I want. So 100, 100. And then I could have another copy of that pattern at 200, 200, stuff like that. And this would have to be defined up there just so it knows where it is. So this is like some pretty useful shorthand for making stuff, just so you don't have to do a bunch of copy pasting. Because I don't know, I wasn't like super happy with the way this map file format stuff turned out. But I talked about this last time. In the interest of time, and like people didn't seem to be interested in it, I just went with something super simple. But I still tried to make it kind of cool, and also flexible. So like it'll be pretty easy for you to add other things that you want to be contained within the chunk. So I don't know, you could say like enemy, something like that, and then give it whatever you want. It'll be pretty easy for you to do that. Yeah, so this is the like end goal that we want our map files to be. So let's actually start writing them. We'll start with just like the top level stuff. I think that would make the most sense. So this will have not a whole lot of private data. I'm going to go ahead and create a type here called top level params. So this will just be a structure that it'll make it like less typing for us, actually writing some of these functions. Then we have a static string here, in token. So this will just be like this. That corresponds to that. So if we change this to like ASDF, then our map would expect us to end these top level blocks with ASDF, something like that. And all of this is going to be case insensitive. Like our map is going to convert everything to lowercase and then check it. But I still like writing everything uppercase in the map file just because it makes it a bit clearer. So we'll leave that as end. And then what each map actually stores will be an unordered map of strings to chunk constructors called m_patterns. So that'll be our patterns. Go ahead and include chunk there. And this is what I was saying, like a pattern is basically just a chunk. It contains all the same stuff a chunk can contain, but it doesn't actually like create itself. You have to use it within a chunk to get all of this stuff like written into your map. So, and you can see here that literally it is just a chunk pretty much. And then we'll have a vector of our actual chunks. And then we'll just have a Boolean here used for when we're reading the file to tell us whether or not like we encountered an error and we should stop reading the file. So we'll have 3 top-level functions. We'll have create chunk. All of these will take an input file stream. So we'll have create chunk, have update settings, and create pattern. And these all take in a file and one of these top-level param structs. The reason I'm not using like one of the files that we created in our IO folder here is those are for like reading binary data, reading stuff like a single byte at a time. But obviously all of this is text, so it's just easier for us to make use of like the niceties that the input file stream has, where you can like read in a word at a time and it'll automatically like use white space as a delimiter, stuff like that. Okay, so those are our 3 top-level functions, and in order to make this as easy as possible to write, and as easy for you to extend it, we will use some C++ magic here. I think I'll write the constructor first, though, just so we can see how it'll be used. So our constructor, we'll just take in the file path of what we want to load, and then we need a sprite bank and an engine instance to pass to all of our top-level functions there. Go ahead and delete the copy and move. And then we don't have any pointers, so we don't need a destructor. And then our void draw, for now, we're just going to draw all of our chunks. we will come back to this later and change it so that it'll only draw the chunk that our player is currently in. Because really that's the whole reason behind even splitting up our maps into chunks at all, is so that it's like different units of processing. So we don't need to process and draw everything every frame. We just need to draw like the stuff around where the player is. But at this point, we don't even really have a system for like what a player is pretty much. So that like we can't write that yet. But we'll come back to this. So our map constructor will just sort of like initialize the well, not initialize, but create the file, and then read from it until either the end of the file is reached or some error is hit, and this abort flag is set. Okay. I'll just copy this, have our map, go ahead and set abort to false. Okay. So we'll read from our file here. This standard iOS binary, I'm not sure if this is necessary, and it might depend on the platform. But what I'm pretty sure this does is it prevents any sort of like localization stuff from happening. Like when you write to a file, it prevents your operating system from getting in the way and like messing with the format of it. It just essentially it makes sure that whatever you write out to the file in your C++ code, like that exact same bit pattern will end up in the file, and that's what we want. In this case, it's not writing though; it's reading. So we want to make sure that whatever we read in is exactly what is in the file. And then if it's not open, there was some type of error. We can just return here. We don't need to set abort or anything. Then we'll create our top level params with the stuff we were passed. We'll have sort of a buffer to store the current word that we've read. And now here's the like tricky part. So we could in here we'd do like while this, I don't know how to say that, but while like it just reads in the next word of the file into this string here until there are no more words in the file. So you get each word separately. Now we could have a whole bunch of crazy complex logic here that's like if word equals, you know, chunk, then we'll do create chunk or whatever, or settings or pattern, we'll do update settings or create pattern. But the problem is that, well, I mean, A, that's really messy. B, it makes it hard for you to extend it yourself. But C, each of these has like subroutines that it needs to call. Like for create chunk, you can add all that stuff to the chunk. So we'll have like void add tile, void add rect, void add pattern, and then eventually we'll have light. And all of these also have to read from the same file. So it just makes it like way cleaner if we, instead of doing everything in our constructor here, we pass this file to our subroutine and let that subroutine use the file as it wants. And then when it's done reading from the file, it'll return control back here, and this will go on to the next sort of top level block that we need. And the way we're going to do this is with some neat use of the template system. So this will be kind of similar, I guess, to what we did with the shaders. We just made some like pretty interesting use of the template system here to make it very easy to write new set uniform functions. That was more or less like a trial run for this, I guess, because this is a bit more complicated. So what we'll do is we'll just have a function called execute. And this will take in all the information it needs to determine like which of these functions to actually run. So it takes in a map, which I'll talk about in a minute. The last word that was read, the file stream, and whatever else we need to pass it. So the first thing it's going to do is math.toLower on our word here, which we wrote way back at the beginning, which just takes a string and converts it all to lowercase. That's what I was saying. Like, it's not. I mean, you could have it like be super verbose, but this is such a loose like file format that if the user writes int like that, it shouldn't be a big deal, I don't think. So we'll just convert everything to lowercase. Now, what this word will be is, well, I think I'll just finish the constructor here. So while we read the next word and execute on some map given the current word, our file path, and then whatever arguments, and there hasn't been an error, so we don't want to abort, we'll just run forever. Because if you notice here, execute returns a Boolean. So while there's still data in the file and we execute whatever's appropriate for the last word read, and there's no problems there, and the abort flag isn't set, just go. And then eventually one of these things will happen. Either there's an error and we've reported it, so we just break out of the loop, we don't want to read any more of the map file. Execute returns false, or we've reached the end of the file and this returns false. And then at that point, all we need to do is close our file and we're done. So we're sort of relying on execute here to like do everything for us, basically. And so let's talk about this map, what this map is. So execute is going to be used not only to run our top level functions, create chunk, update settings, and create pattern, but also all of their sub functions. And so this map is going to be this unordered map of strings to t, which I've just called a type name t here. It's going to be a map of like words, so identifiers within our file, so like pattern, tile, rect, light, that map to a specific function. So the pattern word will map to this create pattern, tile will map to add tile, and so on. And because all of this stuff is like happens in stages, I guess, like stuff has to be nested within other stuff. Like you can't just create a tile, it has to be created within a chunk. We actually need separate maps to store this stuff in like separate arrays. So I'll just write one of those out now. And this is like some weird syntax, but I think it's pretty cool. So I'll write it and then talk about it. So that's our type there. One of the types we'll be storing. And we will actually create a map here. So we'll do like chunk, and that will be and map create chunk. And then we'll also have setting and pattern. So this will be create or update settings and create pattern. Okay, so this is pretty crazy. So we're using Typedef here, which we did use briefly again in this core file, just to like rename some of these underscore t types to what I wanted to call them. But this is a pretty powerful tool. Otherwise, we'd have to like write all this out right here. I don't know, it'd just be really messy. But what this is we are naming a type of function. And this function, it returns void. That's what this means. The name of the function is genfunc, so generation function. It returns void. It is a member function of the map class. That's what this means. So this star just means pointer. But this map : means it must be a function defined within the map like namespace or within the map class. So it's a member function, a pointer to a member function of map that returns void and takes in a reference to an input file stream and a reference to one of these top level param structs. And we're calling that genfunc. Now we're storing a map of these, of strings to these. Again, the string is just like the English word that we will be using in our map file. And then what that English word maps to is a pointer to the function we want to run when we encounter that word. So when we encounter chunk, we'll want to run the create chunk function, and then that will look through a different map and say, okay, do I need to add a tile, a rect, a pattern, or a light? What? And settings, similarly, will say, okay, I've hit settings, so I'm going to go to update settings, and then that will look in a separate map and say, okay, do I need to update the clear color or set the scale or what? And same thing for pattern. So that's all this is. It's static, just because it's not really part of any one object. Const, because it's never going to change, but inline. So I'm not entirely sure why this can't be const expression. I think it's because we're using pointers here, and those like can't be guaranteed to be in the same spot. I don't know. Like theoretically, it could be. I think you could just like have it some offset, but that's not how C++ does it. So just this inline const static means that we can define it in this file here. The inline serves no other purpose than that. But yeah, so this is our top level like generation functions there. And then I've already written out these add tile, add rect, and add pattern, but we're not actually going to use those yet. So I'll just leave it at this for now. So this is what we'll be passing in our main loop here in our map. So we'll execute on gen functions, because these are like the top level things. So this runs when we start reading our file, and we want to start at some top level block. So now we can go back and finish our execute function here. So it takes in the last word that was read. So like in this case, the first word read will be setting, and that'll be stored in word here. So this little double arrow operator means put the word setting in our string word here. And then we pass that to execute. So execute now has that. We convert it to lowercase just because these are all lowercase. And if this wasn't setting, if this was like, I don't know, ABC, it'll look and say, okay, ABC is not in the map that we've been passed here. So we'll throw an error. So if we've been passed some invalid identifier for like the current block, the current scope, just say invalid keyword and then abort. And we'll have to set abort equal to true just so that our main loop will break out here. I guess it would anyways because we're returning false. There we go. Now this is some more weird syntax. So we have this, the const pointer to the current object, pointing to dereferencing the second element of the result we got from the map. Okay, so the result that we got from the map is going to be one of these. It's going to be one of these pairs. So result.first will be a string, but we're not interested in that. We want to run the function, so we'll get result.second. So that's what this does. This gets the function. But remember, this is a function pointer. We've used the little ampersand here. This is a function pointer. So we dereference that pointer with the sort of star operator there, and then this has to point to it. So I don't know, this syntax like makes halfway sense, but some of it seems kind of arbitrary. I don't know, but either way, this whole little parentheses chunk here basically just means give me the name of the function I want to run. So like create chunk, update settings, or create pattern, and then just call it normally, just pass in the arguments. And this is why we've done it in sort of this generic way where we have type name args instead of, like, we could just make this top level params, right? Because that's all we're passing in here. And that would work fine for these functions because the signature of these top level ones is input file stream and then params. But for like our add tile and stuff, it won't be that. It'll be different. So we'll have like an input stream still, but then we'll take in a sprite bank and a chunk constructor. And obviously, if you hard code this to taking in top level params, that won't work. So we just take in whatever else here, and then it'll pass the input file stream first, which all of our functions will have in common, and then whatever else you need. So that's a pretty neat function, I think. It makes writing this much, much easier. Yeah, so we do have another helper function here. I guess I'll just go ahead and write this called check end. So this will just be used for like the top level blocks that need to end with this end identifier here, whatever we've set as our end token. And this will just check if the current word is equal to that. If not, it'll throw an error, because we'll be using this several times. So check if word is equal to end token. Again, we don't care about case, so we'll just do equals ignore case. If it's not, section must be terminated by our end token. We'll set abort to true, and then this returns a bool as well, so we'll return not im abort. So if im abort is false, which means this check didn't run, so word is equal to end, which is correct, then this will return true. Otherwise, this has been set to true, so that'll return false. Okay, so now we can actually get into writing some of these. So I'll start with just the top level, all these top level ones, and then we'll get into add tile, add rect, all that. Have create chunk, and then update settings and update pattern. Okay, so create chunk is pretty short. All these are pretty short, actually. That's a benefit of sort of like generalizing or templatizing, I guess, a lot of this work out into the execute function. Is it's each thing is like its own self-contained thing, and it's only a couple lines. And now you can see why we've needed to create this sort of weird like way of creating chunks. Instead of just passing everything in right there, we pass in this chunk constructor, because when we start creating a chunk, which basically means whenever we read this token, we want to start adding stuff to that chunk. But obviously this can be, you know, as many lines as you want. You can't add it all at once. Or I suppose you could, but it would be messier. So instead we just have this separate object that will then pass down to this add tile, add rect, and they'll like add themselves to the constructor. And then when we're done with that, we'll actually do imchunks.emplaceback with our constructor. So everything that's been added to our constructor, once we're done reading the current chunk, so once we've hit this end token, we will actually create a chunk. So all this takes in, like the arguments, as I've called them, is the x and y. So we'll just read those in. And this is what I was talking about, like why it's good to use the input file stream, is because it'll do this like type conversion for us. It'll not only read this whole thing and like stop at the white space that it needs to, but it'll also say, okay, I'm trying to read in a float, so I'll convert whatever value this is into a float. Very nice, very clean. So all of our functions that like spawn child functions, I guess we need like a single string buffer to store the current word. So we're gonna have that a lot. So I guess I'll go ahead and make another function here. So we want to check, we want to basically loop through, like get each word from the file. And while that word is not equal to end, we want to keep reading. And we will execute on some other map that we'll create in a minute, given the current word in and then the arguments we take is input file stream, bank, and then constructor. So we'll do params.bank, and then the constructor that we're creating, and then that's it. And then once we're done reading that loop, if not check end, so if the last word we read was not the end token, then it probably means we either hit the end of the file or some other error happened, and so we'll say like, we'll just call this and say the section must be terminated by end. But this math equals ignore case thing, like I'm going to move that out into a separate function here because we're going to use that a lot. So isEnd will just take a word, and if that word is equal to our end token, return true. So while we get the next word, and that next word is not the end, we will execute. Okay, so we have everything we need except the map that we need to pass in. So we're going to do something very similar to this. I'll just go ahead and copy this. But instead of genfunc, we're going to have mapfunc, or sorry, chunk. And that takes in an input stream, sprite bank, and a chunk constructor. And we'll have a map called schunk functions. And the words we have there for now are tile, rect, and pattern. With add tile, add rect, and add pattern. Just like that. And this is yelling at me for some reason. Why is that? Oh, it's because I've actually didn't give all these the proper arguments. So they're all going to use this format, so we need to give them all those arguments, and that should be fine. Okay, there we go. And now this, and eventually we'll come back and add like light here as well. So now this new map, schunk functions, is going to be what we will, like the sub process we'll call from our create chunk method, just like that. So we can actually go ahead and write those. That would probably make more sense than going on to the other ones here. So let's get these in. And again, these will be super, super simple. Add tile, just create a tile, and then read stuff in. So we'll need a path and then frames and time. We need to store these separately because if we look at our map, or sorry, our tile, the first thing it takes is a sprite pointer, and we have to like actually get that pointer. Obviously, there's no way to give that sprite pointer in part of the map data, so we just give a description of the file with the file name and then the frames and time, and then try and find it. So we'll get the path first, and the frames and the time, and then we can go ahead and keep reading in. We'll read in the coordinates, so x and y, then the layer and rigid, which we will use eventually. Then we'll set our sprite equal to bank.put path frames time. So this will get the sprite if it exists, otherwise it'll create a new one and then just return that. And this is why we needed a sprite bank for these functions. And then, of course, I mentioned this, that everything within a chunk will be offset by that chunk's like bottom left coordinate. So once we've read in the sort of local position of our tile, we need to offset it by the position of our actual chunk, which is stored in this constructor object. And then once we've created that tile, we will add it to our constructor's vector of tiles. Okay, so that's add tile. Add rect is pretty similar. Just going to add a bunch of tiles. We'll still need the path. So we'll just Let's read everything in. If it's not like clear, the order that we read stuff in here, basically it dictates the order that you have to write stuff in your map file. So this format I have for add tile currently is not compatible with what I wrote in here, because here the order is like file path, XY, frames time, and then layer and rigid. But here I'm reading in path, frames time, in that order. So this should be 2, 500, there, like that. And we do want everything to be in a certain order. You could have a more complicated thing, like sort of like a JSON type thing where every value is like named, and that might be better, but I don't know. This stuff is so small, like I don't know. There aren't like that many arguments to worry about. Okay, so we're reading everything in, like the description of our rect. And remember, a rect is just like a rectangle of tiles. So we're just gonna basically loop through the coordinates that we've gotten and create a bunch of new tiles. Get the sprite as before. Then get the width and height. Oh, need to include that. That's just for ease of use. And now we will actually create all of our tiles. So we'll do Y first, and then X. This is just the way I prefer to think about it. Constructor.tiles. We can do in place back here. So the constructor for a tile, the order is sprite, and then a vec2 position. So that'll be X, like the X and Y here are the base coordinates of the rect, the bottom left. But then for each tile, we need to sort of move its position according to, these X according to our position in the loop. So we'll do X times J plus the width of the sprite, and Y plus I times the height. And then we need to add that to the base position of the constructor itself. And then we have layer and rigid. And I've definitely messed something up with the parentheses here. There we go. So that's a pretty long line, but it just sort of maps to this, the order that we give arguments to our sprite, or our tile. We have sprite pointer, position, layer, rigid, sprite pointer, position, layer, rigid, just like that. And then we don't actually need to return anything because, well, I mean, it's void obviously, but we've already added, like we add stuff to our constructor tiles list as we loop through, rather than here where we like create a tile, a standalone tile, and then add it. So next is add pattern. So this, you give it a name first, and then the X and Y offset. So the first thing to do is check if there is actually a pattern with the name we've given. Remember, we're storing this map of strings to patterns here. Whoa. And if it doesn't exist, there's an error, so we'll print something and then abort. Unknown pattern. Like that. Otherwise, we will have this new call that we're going to go and write in our chunk constructor. It's a method called merge. Because remember, patterns are just chunk constructors. So our merge method here will take our existing constructor, the like chunk that we're currently creating, and we have this other chunk constructor as a pattern, some named pattern that we've previously defined, and we want to get all of the contents of that pattern and add it to our constructor at the given offset. Add it to the chunk constructor we're working on right now. So let's go ahead and write that. That'll be in chunk.h. And this is pretty simple. Basically just a loop. But note here that I did not take in this chunk constructor by reference. I'm taking this in by copy, and we'll see why in a second. So we'll go through each tile in the constructor that we're merging with and apply not only this current chunk constructor's base position, but also whatever offset we've passed in. So we'll offset it by that. And then we'll do a tiles.reserve here, just to make sure we have enough space. This, like, it's not necessary, but it can speed it up. Just reduce allocations. And then we can write this entire other.tiles vector into our current tiles vector like this, giving it some iterators. So the reason this isn't a reference here is because we are changing the coordinates of the tiles in this chunk constructor, which we don't want to do because this chunk constructor, remember, is just a pattern, and a pattern should be reusable no matter where. Like the only time the position of anything within a pattern should be specified is when you add it to a chunk that already has some position and also give it an offset. So like if this were a reference, then the position of the actual tiles within our pattern would change. So the next time we use that pattern, it would be messed up, basically. So that's why I don't take it in by reference there. Okay, so that's add pattern. I think we'll just go ahead and finish off just go on down the list here. So we have update settings. We're only going to have two functions here. We'll have set clear color, which will take an input stream reference and an engine instance. And then we will have set pixel size, like that. And then we will go ahead and move these two new functions into another map called setting functions. Just copy this again. Takes an input file stream and an engine instance. And the keywords we want here will be clear and size. So size, you could do scale as well, but let's do size. And that will be set clear color and set pixel size. Of course, this should be setting like that. Okay. Now that we have that, we can actually write our update settings method here, and then these other two. Okay, so our update settings will be very similar to our create chunk. Sort of all the top level ones have this basic like format where you have a buffer for the current word. You read into that word while it's not the end token, and you execute you execute on your like child functions map according to whatever the word is, and you pass in all the stuff you need for that, and then at the end you check if you did actually get to the end token, and if not, you throw an error. And this, we don't actually need that here because we're not doing anything after this, so this can just be check-end. All right, our clear color, these are going to be dead simple. Just reading in 3 floats, RGB, and then engine.setClearColor, which we'll define in a minute, to RG and B. And then pixel size here, just need a single float, and engine.setPixelSize. Okay, so let's go ahead and write those. They're very, very simple. Where's our core file? Here it is. So these are just going to be like 2 more wrapper functions for our OpenGL instance. So R, G, and B. And then set pixel size. Just like that. And then in our actual function here, or in our graphics library core, need to actually write those functions. So this will be GL clear color, RGB, and 1. We're not letting the user specify an alpha. And then set pixel size. We will have to do some small computations here just to adjust our simulated pixel stuff. But it's basically just this. So just recalculate. Oh yeah, so we're not actually storing these yet. So when we set our pixel size, we need to recalculate the size of each simulated pixel in OpenGL coordinates. And to do that, we need to have a window width and height, which up to this point we haven't had a need to store, but now we will actually store them just in some uints. Just like that. So whenever we create this, we'll just set those, and then we'll be able to use them down here whenever we set the pixel size. Okay, so that should have fixed all these errors. Looks like it did. Next is pattern, create pattern, which is very simple, doesn't even have any child functions. Well, it kind of does, but you'll see. For some reason, I can't type constructor. So we'll get the name of it. That's sort of the first argument. After we read, like the block name is pattern, then we need the name of the pattern we're creating. And you could have some error system here where like if a pattern with the given name already exists, you could like throw an error. I'm not going to do that though. Like, I don't know, it would be trivial to do it if you want, but like I was thinking it could be useful where if you have a pattern with the same name to like redefine that later on for use in different chunks. I don't know, but if you want to do that, that's just like 3 lines of code. So while we have a next word, and that word is not the end token, if we execute, the map we're going to use is just chunk functions, because all a pattern is a chunk, or a chunk constructor. Here we'll do if not check end. And then instead of actually creating a chunk with our chunk constructor, we will create a pattern. Just insert it into our map with the given name. And there we go. So now we should actually be able to test this stuff. I rebuild here. Probably some errors. Of course. Love to see it. The compiler's yelling at me because in our, that's probably in create chunk, yes, mchunks.emplaceback constructor, this is doing the exact same thing that we saw here with the sprite group. So we actually have to define a move constructor here for our chunk class. But that, in this case, like the compiler catching that is not a big deal. Like we could just use the default compiler generated move constructor, but still, I like to know what's actually happening and have complete control over it. So just copy the vector and then move, or sorry, copy our vec2 and then move the actual standard vector there. That should be all we need. And perfect. You can see there were some weird warnings here. Not all control paths return a value. Just in our execute thing there. It would probably return, I don't know, it might actually return false by default. So that's probably pretty important that you have return true there. Okay, yeah, so that looks like it. Now let's actually test this in our main file. And this is the best part. We just get to look at all this junk and just like delete it. Just get rid of all of it. Don't need any of that. Perfect. We don't even need render.draw. I think we'll still keep this camera stuff. But all we'll need now is a map.draw. Of course, I need to include map and then actually create one. And the map does, like the map constructor, it takes in a sprite bank. So eventually we'll like clean this up. That'll be part of the world like class that I was talking about before. But for now, we'll just define it here. We don't really have anywhere else to put it. Okay, so this should read stuff from our map file. Let's just build one last time to make sure everything's good. Then if we run, we'll probably get some errors here because I just sort of wrote this off the top of my head. It probably isn't in the right format, and we should definitely get at least one error saying that we have this light token here, which is not recognized. And you can see that we kind of do. It says pattern section must be terminated by end. The reason it's saying that, actually, I'm surprised it didn't run this. I was expecting it to say invalid keyword light. I wonder why that is. Let's see. In our create pattern, we're passing chunk functions. Let's just do some debugging here and print out result first.c string. Okay, so it's got setting clear size good, pattern tile rect good, and then that seems to be failing early for some reason. It could be, I'm thinking it's because I actually specified incorrect values for this rect here, so I'll just delete that for the time being and see what we get. Yeah, there it is. Okay, invalid keyword light aborting. And then it says pattern must be terminated by end, and you can see here it doesn't really crash, but it just like doesn't actually finish making the map. So this map.draw function is returning nothing because no vertex data was actually created. Okay, so let's just remove that light there and see what we get. Okay. So we have one thing here and one thing there. Excellent. The reason these are where they are is because our chunk is offset to -100 and -100, so like somewhere down here. And then we're specifying this pattern, which just has a single tile with 0 inherent offset. And we're specifying that at 100, 100, and 200, 200, but those are within our chunk, so these are relative to the bottom left coordinate of our chunk. So 100, 100 is just going to be added to -100, -100, so that gets 0. So if I load this up again, you'll see that the this first one here is like right at 0, 0. This is like the middle of the screen, the exact middle of the coordinate system, 0, 0. And then 200, 200 is just going to be 100 pixels in both axes up this way. And just to prove that these values are like true, because those are kind of big. Let's see. I wonder what the actual size of that file is, or the size of that image, and then we can just where's this? We'll just offset it by that just to make sure it lines up correctly. Okay, so we have test.bmp properties. This is a 16 by 32. So that 32 is because it's 2 frames. So really it's 16 by 16. So I'll leave that at 100, 100, and then set this at 116 in the X and 100 in the Y. So now we should have 2 right next to each other. Interesting. Seems to be somewhat incorrect. Is that the right file? Is that really 16 by 16? Oh, I looked at test 2, no wonder. Yeah, okay, 41 by 82, that seems more correct. So this should instead be 141. And now they should be right next to each other. Perfect. So we can see that there. Another way to do this would just be, we can still use pattern, we'll have a single pattern. We'll make this a rect instead. So let's see what that takes. It takes path, frames, time, good, XY, good. Then we need a width, height. So these obviously have to be non-zero. Width I'll just set to 2 and height to 1, so this should give us the same result. And then layer and rigid, we're not using it. And there we go. Get that, and you can see now if I copy this and put it up at 200, 200, we will have 4 total tiles in this sort of like original arrangement that we had. There we go. So that's like our map stuff. As I've said, we will be coming back a bit later and adding stuff to it. Lighting. I think lighting is the only thing we'll be adding, which is very easy to do because of like all this sort of cool groundwork we did with just making everything easy to write. And lighting is the next like big chunk that we'll be doing. But yeah, like as you can see, this is a lot of code and it's like a good amount of logic. But the way it's designed makes it very easy to add on to it. It's like extremely modular. So not only can you add a new type of thing that you want to create in a chunk, you could also add a new top level block if you want. I don't know what I don't know what you'd have here, like just something with end, and then it would have whatever else you want in there. And you can do that all just by creating these new functions and updating the existing maps, or maybe creating some new maps of your own. And then yeah, just defining everything like this in its own sort of modular function. And if I scroll back up to the top here, this is the result. This is like the only code that's running when we actually create our map. We just read the file. If it doesn't exist, throw an error. Just set up some values there, and then just a single while loop, which is beautiful. This is very, very, very easy to read. I think. Well, I guess not. Like the code isn't easy to read. When I actually go back and add comments, it'll be very easy to read. Certainly much easier than if all of this was defined within our while loop here, rather than passed off to this sort of generic execute function and done all in its own subroutines. So yeah, hopefully you enjoyed this. This is a pretty big step. I can definitely tell that like I'm able to go faster here now that we're not doing everything live. I don't even know how long this video is. It's probably less than an hour and a half though. But yeah, so I sort of like hyped up the whole rendering pipeline thing last time, and talked about like how difficult it is and everything. Um, it really is. Like just because we've done it very quickly here, I'm sure you don't understand all of it, which is totally fine. But we're not done yet. This is our static rendering pipeline. This is map data, like stuff that we've got here. We still have no system for stuff that moves around the screen. We don't even support that like within our graphics library yet, let alone within our engine or our maps or anything like that. And like beyond that, we haven't done collisions or anything. I'm currently working on like the material for handling collisions. Like I've already written the code, but I'm just sort of trying to structure it out in a presentable way, and that's pretty tough. Like that's sort of like the dynamic part of our rendering pipeline, and that's a whole different thing. So like I don't want it to seem like I hyped this up a lot, said how hard it was, and then we did it in like 2.5 hours or whatever, because it will get harder. But that's in a little while. Next time we're doing lighting, which is also pretty simple. We are going to have to go back and make some adjustments to our graphics library there and add some new stuff as well. But lighting is very cool. I think it's I don't know. It's not necessary for any game, like especially 2D games. But I think it is. It does add a nice level of polish to everything, just making the whole world seem more interesting, really. So hopefully you're looking for starting lighting next time. There's some interesting math as well that we'll go over, and modifying our shaders here, which is always fun. But yeah, just play around with this map file system, see if you can get some cool stuff going. And I'm looking forward to seeing you next time.